Let's write out some algebraic expressions, shall we? We're going to do 6 of them, and we're looking for keywords like difference and of. And then we're going to just, put things in order. So first things first, the difference of 10 and 5. So difference means minus. You have 10, you have 5. The difference of 10 and 5 means 10 minus 5, like that. The quotient means divided by. The quotient of 14 and 7 means 14 divided by 7. Now, you might have a teacher that would want you to write it out like this. It's all good, as the 90s rappers would say. You decreased by 17. Decreased means minus again. So when you take you, or as Soldier Boy would say, you, and decrease it by 17, you're going to take u minus 17 because you're taking away the 17. Huh? 3 more, halfway done. Half of 14 is literally going to be 1/2. Now, whenever you have like half of something, a third of something, whatever, that of means times. So half of 14 is half times 14, like that. X increased by 6 is going to be added to. So X increased by 6 is going to be X plus 6. And last but not least, we've got product. So the product, which means times, of X and 7 is going to be X times 7. So there's a couple algebraic expressions for you. Starting off Algebra 1 stuff nice and easy, baby. Evaluate the expression. Well, boys and girls, this is an order of operations problem, also known as PEMDAS. Now, PEMDAS stands for do everything inside parentheses first. I don't see any. Do all of the exponents next. I don't see any. Multiply and divide left to right. This does not mean multiply then divide. This means go left to right and do any multiplication or division. I see that. 32 divided by 4 is 8. So drop down the 8, and 9 minus just comes along for the ride. Now what comes after that is add or subtract left to right. 9 minus 8 is 1, and that's going to be my answer. Okay, so evaluate the expression when given just numbers as PEMDAS or some other weird thing that teachers use nowadays. I don't know, but that's what I did, and I'm sticking with it. Evaluate the expression. So I see a bunch of numbers and symbols, which tells me this is PEMDAS. Now, PEMDAS is an acronym. And what you do first is you start out with everything inside the parentheses. Well, I have something inside the parentheses. It's 6 minus 4, which becomes 2. So drop down the times 49, drop down the divided by 7. All right. What you do next is you do exponents. Well, I don't have any. Then you do multiply and divide left to right. This does not necessarily mean you have to multiply and the divide. You just have to go left to right. So 2 times 49 is 98. Drop down the divided by 7. Okay, 98 divided by 7 is 14. Took me a minute there, so I made a sound. But that's that. No addition or subtraction to worry about. Just a couple P's, a couple MD's, and we are D for done. Evaluate the expression. Well, whenever you're given just numbers and a bunch of symbols, parentheses, whatever, you are thinking PEMDAS. Now, what PEMDAS means is you do everything inside the parentheses first. And you might be looking at this guy and saying, I only see one set of parentheses. Friends, when you have a fraction and you have multiple things going on in one side of the fraction, that's invisible parentheses. It's a grouping symbol. So I have 2 sets of parentheses that I can do first. Okay, 8 doesn't change. 5 minus 1 becomes 4. Okay, drop down the times symbol. Now I have this parentheses where I can do 3 plus 6, which becomes 9. So I have 2 sets of parentheses technically. So parentheses, done, check. 2 of them. Any exponents? Nah. Now I do multiply, divide, left to right. Now I see a divide and 2 multiply. And if you might be thinking, I don't see a division symbol, I do. It's right there, that fraction bar. 8 divided by 4 is 2. Do that first. Drop down the times, parentheses 9 times 3. Now we keep multiplying left to right. 2 times 9 is 18. Drop down times 3. Keep multiplying left to right. 18 times 3 is 54, and I'm done. No adding, no subtracting, nothing like that. That's PEMDAS for you. Evaluate using the values given. Now, what we have here is we have a bunch of variables and then numbers that represent those variables. This process is called substitution, where you replace the letters with the numbers given. So what I have is I have z times a huge parentheses with a plus sign in it. Anytime you substitute a number in for a variable, you have to replace it with parentheses. So that z right here becomes parentheses 6. That x right there also becomes parentheses 6. And that y right there becomes parentheses 8. Now, the parentheses might seem like a bit too much, but you're just supposed to do it anyway because rules. Now, this is a PEMDAS problem. PEMDAS says do everything inside parentheses first. This does not mean parentheses first. This means everything inside the parentheses. What I have going on inside this big red parentheses is 8 plus 6, or 6 plus 8. The order doesn't really matter because you're adding. 6 plus 8 is 14. That 6 still lives along the outside. Now you go through PEMDAS and you realize, all right, no exponents. All I have to do is just multiply the guy. And multiplying 6 times 14 is going to give me 84. Okay? So whenever you're given an evaluation problem with variables, letters, substitute those numbers in. You're probably going to do some PEMDAS and end up with a number just like that. Evaluate using the values given. Now what I have here is I have an expression with some variables, with some numbers, with some symbols, and I'm telling you that these variables mean 6 and 4 for H and J respectively. So what I do is I write out the numbers and symbols as usual. Anytime that I'm going to substitute a variable with a number, I'm going to have to replace that variable with the parentheses and then that number. So h squared becomes parentheses 6 squared. Then do it again. We have minus j, so minus 4. J is 4, so let me get my colors straight. Okay, now that we're done this parentheses here, I'm going to close it and then divide it by 2. Now this, boys and girls, is a PEMDAS problem. And what PEMDAS says is you go inside the parentheses first and do what you can in there. Inside these parentheses, I have my own little PEMDAS problem. I'm adding, I'm having exponents, and I'm subtracting. The first thing you do in PEMDAS is exponents. So parentheses 6 times itself becomes 36. So I drop down 6 plus 36 minus parentheses 4, and then divided by 2, all of it still comes along for the ride. I'm still inside the parentheses. Now all I have is addition and subtraction, so you move left to right. 6 plus 36 is 42. So 42 minus parentheses 4, close it, divide it by 2. 42 minus 4 is 38. And 38 divided by 2 is 19. So that's a pretty gross looking evaluation problem, but we did it, and boy was it fun. Name the sets or sets to which each number belongs. There's two primary types of numbers. You got yourself your rational numbers, and you have yourself your irrational numbers. Okay, now irrational numbers are crazy numbers, like square root of 80. I don't know what that is, but I do know it's going to give me some terrible decimal. So like here's a terrible decimal, blah, 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 blah. Those are irrational numbers. Rational numbers are numbers that can be written out as a fraction. Okay, so underneath your rational numbers, Okay, you have your own set of numbers. So rational numbers, like regular old rational numbers, can be stuff like a half or 4.3 repeating. Those are rational. Living within the rational are my integers. Okay, my integer numbers are numbers like 1, -8. They can be any number, positive or negative, as long as it's not a decimal or a fraction. Living inside your integers, you also have your whole numbers, and those are basically the numbers that start out with 0, 1, 2, 3, and keep going on forever and ever and ever. So with most of these, I can give these guys several names. For example, -5 is an integer. It's also a rational. Okay, number 11 is a whole number. It's also an integer. It's also rational. It's all of those because it lives inside the whole number realm that lives inside the integer realm, which lives inside the rational realm. The rational realm sounds fun. Square root of 30. Do you know what the square root of 30 is? No, me neither. So it's gross. It's irrational. And last but not least, you have 17 over 3. This is a fraction, which is rational and only rational. Okay, it can't be written as a regular whole number or an integer. Okay, so this is how you name the set or sets when given a number. And of course, there's other numbers that we could use, but we used a couple. All of them were positive except for u. And yeah, several names for some of them. Hope this helps. Find the sum. So this is not a PEMDAS problem. This is just making sure we know how to deal with adding positives and negatives when the negatives are a little wacky. All right, so work your way left to right. 2 plus 6 is 8. 8 then plus -7 plus 10. Now plus a -7, if you need to write it out, if you need to, is the same as 8 minus 7. So 8 minus 7 is 1. Drop down the plus 10, and 1 plus 10 is 11. So nothing crazy here. It's just understanding that when you add a negative, it's the same as subtracting. And when you have 8 minus 7, that's fine. Nothing to worry about. Don't have to worry about negative answers. We could just do the problem. Find the sum. Now, this one's going to be very unpleasant because not only do we have decimals, we have a larger negative number than a positive number. So this is what you do. If I have for example, let's go off to the side. If I have something like 5 plus -8, the negative digit is larger than the positive digit. What you do is you subtract the numbers like you normally would, like so. But since the larger digit is negative, you keep your answer negative. We're going to do the same thing over here. And we're going to go off to the side and actually do what I just did and say, all right, well, let's take our larger number, 2.4. Let's subtract 0.085 and treat it like it's a regular number. So let me throw a 0 right there. All right, let me carry the 1, take away from u. So 10 minus 5 is 5. 3 minus 8 can't do it, so let's take away from u and make you 13. 13 minus 8 is 5. Drop down the decimal. 1 minus 0 is 1. Now in this case, since the negative number was larger, this becomes negative 1.55. Drop down the 4.5. Now, in this case, I have a negative number being added to a positive again. But since the positive number is larger, my answer is going to remain positive. So I'm going to once again go off to the side and do 4.5 minus 1.55, but I'm going to make sure that my answer remains positive. We have to attach a 0 there, okay? Carry the 1, borrow the 1, and whatever the words are. 10 minus 5 is 5. 4 minus 5 can't do it, so borrow from here and call you 14. 14 minus 5 is 9. Okay, there's your decimal. 3 minus 1 is 2. So at the end of all of this, my final answer is going to be 2.95. Baby. Find the sum. So this is what I'm dealing with here. I'm dealing with adding two fractions that have different denominators. When you have fractions with different denominators and you need to add them, you need to have a least common denominator. Now my least common denominator for 3 and 5 is 15. How do I make a 3 15? Multiply the top and the bottom by 5. I'm allowed to multiply any fraction by 1 because 5 over 5 is 1. I'm going to do the same thing here. I need to make this denominator 15, so I'm going to multiply the top and the bottom by 3. When you multiply fractions, you multiply straight across the top, so 5 times 5 is 25. 5 times 3 is 15, plus, now this is a negative, so I'm going to keep it negative. 7 times 3 is 21, 9 plus 10, and 5 times 3 is 15. Now, 25 over 15 is more than 21 over 15. So when I add a negative, I'm actually subtracting, and this type of problem looks pretty good to me. Okay, so I'm turning plus a negative into a minus sign. All right, when you add or subtract fractions that now have the same denominator, you do the math in the numerator, 25 minus 21, and get 4. 15 on the bottom stays the same, and our final answer is going to be 4 over 15. Wasn't that great? Evaluate 1.7 minus negative 0.8 plus 4.013. Whenever you see minus a negative, automatically turn that into a plus sign. All right, so let me rewrite this out. 1.7 plus 0.8 plus 4.013. Now I like to do these, well actually no, I can do this in my head. 1.7 plus 0.8 is going to be 2.5. Drop down the plus 4.013. I can't do this one in my head. So if you need to go off to the side and stack them up like you normally would, 2.5, line up the decimals, 4.013, attach any zeros if necessary, and you're just adding. 0 plus 3 is 0. 0 plus 1 is 1. 5 plus 0 is 5. Decimal, 2 plus 4 is 6. So this guy ends up being 6.513. Evaluate. Ooh, gross, a fraction minus a negative fraction. Ooh, and double gross. I have different denominators. This is what I'm going to do before I deal with those denominators. See that negative of a negative? Just make it a positive, right? Whenever you have a double negative, make it a positive. So now I have 7 over 4 plus 1 over 2. What I need to do now is add these fractions, but I can't. I can't because the denominators are different. Well, if I were to multiply u by 2 over 2, I would then have a denominator of 4 because 2 times 2 is 4, and I don't have to do anything with u. So I have 7 over 4, u stay the same. 1 times 2 is, let me get my calculator, 2, and 2 times 2 is 4. Whenever you're adding fractions of the same denominator, keep the denominator the same, add the numerators, and you're done. Evaluate each quotient. We're just doing division here. So right off the bat, we have something lovely. 10 divided by 5, 2. I can handle that. Oh, but negatives. Remember, a negative divided by a negative becomes a positive, right? A positive divided by a negative becomes negative, and a negative divided by a positive is also negative. This is the negative divided by a positive category, which means it's going to be negative. And then you do 24 divided by 12, that's going to be 2. So negative 24 divided by 12 is negative 2. This is a negative divided by a negative. You become a positive. 20 divided by 2 is 10, so negative 20 divided by negative 2 is positive 10. You are also a negative divided by a negative, so you also become positive. 300 divided by 20 is going to be 15, so negative 300 divided by negative 20 is a positive 15. Quotients. Multiply 8 times -6 times -3. The trick here is making sure you feel comfortable about multiplying positives and negatives together. Always go left to right if all we're doing is multiplying. 8 times -6, positive times negative is negative, and 8 times 6 is 48. Drop down the times -3. A negative times a negative is a positive, so our answer is going to be positive. And 48 times 3 is 144, I think. Leave in the comments if I'm wrong, but I'm pretty sure that's it. However, the key here is knowing that you have a negative times a negative, which becomes a positive. Isn't that neat? Simplify -6 times a parentheses. Ooh, it's stuff inside the parentheses. Boys and girls, this is called distributive property. Whenever you have a number multiplied to a parentheses and you're adding or subtracting inside the parentheses, take that number and multiply it to everything inside the parentheses. For example, -6 times a is just -6a. One's a number, one's a letter, they don't combine. Drop down the plus sign. -6 times +8 is actually going to be -48. So maybe I did too much with that dropping down the plus sign. So I'm going to get rid of the plus sign and make that -48. And that's distributive property. These two don't combine because one has an A and the other one doesn't. So don't combine them. Distributive property, but it doesn't look like distributive property. We're used to our number living in the front. Now our number is living after the big parentheses with stuff happening inside of it. It doesn't matter. And if you want to, you could even rewrite it as -10 times 1 plus 9x and apply the same exact rules. Again, it doesn't matter whether you go this way or this way and say -10 times 1 is -10 and -10 times -9 is +9, silly me. -10 times +9 is -90. Drop down the x, you're still good and you're still done. The regular 10 is a constant. The regular 90x is a variable term. They don't combine. And that's me trying to make a perfect circle and failing. But still, distributed property. Hope this helps. Let's combine some like terms. Let's say that there's a ninja just floating around, right? And then you look all the way over here and there's 9 of your ninja friends. Well, if you are a ninja, and by the way, if you're like, ninja, I don't see a number there. Buddy, if there's no number in front of a variable, it's invisible 1. So 1 ninja plus 9 of his ninja friends are going to make 10 ninjas. Easy peasy lemon squeezy. But that's not all, of course. You see, we have -10 right here, which is called a constant, and -3 right here, which is also called a constant, and -10 minus 3 means you have -13. 10n and -13 have a variable here and no variable there. They don't combine, so that's our answer. So combining like terms is just taking the numbers that have letters attached to it, and if they're the same letter, you add, subtract, whatever it is you're supposed to do. And these are normal numbers, so you add, subtract, whatever it is you're supposed to do, and we end up with 10 ninjas, and we're taking away 13 13s. Hope this helps. Ooh, -5n plus 3 parentheses 6 plus 7n. This, boys and girls, is distributive property right here, with that guy eventually combining with whatever we get over here. So distributive property is when you have a number attached to a parentheses and you're doing stuff within the parentheses. Take that number and multiply it to both items inside the parentheses. +3 times +6 is 18. +3 times +7 is 21, but then the n comes along for the ride. What about that -5n out there? It's still out there. So -5n, and since 18 is still positive, here's your plus sign. Now what I have is 3 terms, and 2 of the terms are n's. So you combine the -5n with the 21n. So this is basically like saying 21 minus 5, which is 16, n comes along for the ride. Plus 18 drops down, and I have 16n plus 18. They don't combine, because one has a variable and the other one doesn't, which means they're not like terms. So this problem is dunzo funzo. Distributive property here, distributive property there, distributive property everywhere. Let's treat each distributive property different. I have -9 times 6m minus 3 in parentheses. So what that means is you distribute -9 to both. -9 times 6 is -54, and m drops down. -9 times -3 is positive 27 because a negative times a negative is a positive. Jolly good show. Now we have 6, a positive 6 being multiplied to 1, and a positive 6 being multiplied to 4m. 6 times 1 is 6. 6 times positive 4m is plus 24m. Now what we have is a line of numbers, terms, variables, yada, 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 where -54m is like positive 24m. So whenever you're combining like terms and you have the same exact variable, you take the numbers or the coefficients in front and you do whatever it is you're supposed to do with them. -54m plus 24m is -30m. Okay, -54 plus 24 is -30. M comes along for the ride. What do we have left over? 27 plus 6, which is 33. Now you take a look at what you have remaining, and since one of them has an m and the other one doesn't, these guys can't combine, which means this guy right here is your answer. So -30m plus 33, that's it. Find the percent of change to the nearest percent. If you go from 74 hours to 85 hours, what is the percent of change? Well, the percent of change formula is going to be whatever your new value is, which would be this guy. That's our new value, 85. And we're going to subtract away our old value, which is 74. That's me writing out old. And then once we find that number, we divide that whole thing by the old value. So it's going to be new minus old, all divided by old. So what I'm going to do is I'm going to substitute those guys in. I have my new value, which is 85, minus my old value, which is 74, all divided by my old value, which is 74. So whenever you have two numbers being subtracted, added, whatever on one side of a fraction bar, do that. 85 minus 74 is 11, and that leaves us with 11 over 74. Now, this is not a pleasant number, so what we're going to probably have to do is run to the calculator and figure that out. When we do that, we get 0.1486. Now, that's not our answer. Don't circle it. That is a decimal. In order to turn a decimal into a percent, we're going to multiply this by 100. An easier way of doing that, though, is take our decimal and move that to the right twice. So what we get is 86%. Now, the directions here are saying round it to the nearest percent. So 14.86, if you're thinking as like, money, $14.80 is closest to $15. So 14.86 percents is going to be 15%. Listen, I'm keeping all the errors, all the mental gaffes in here because I think it's important. But that's how you do it. New minus old, all over old. Since we are going from a small number to a big number, we are increasing, and we're increasing about 15%. Find the percent of change to the nearest percent. What you're doing is you're finding out what percent of change happens when you go from 117, which is an old value, to 91, which is a brand new value. Now, the equation that we're going to use here is we're going to take the new value that we have, okay, subtract away the old value, and then once we do that, we're going to take that number and divide it from the old value. We'll get a decimal, and when we do, we'll deal with that when we deal with that. The new value was 91. and we're going to subtract away the old value, which is 117. Divide all of that then by that old value, which is 117. Okay, so the first thing that we're going to want to do is 91 divided by 117. And 91 minus 117 is negative 26. Now, this is probably where you're going to need a calculator, unless you're really, really, really good. You run to your calculator and find out what negative 26 divided by 117 is. And you end up with negative 0.2222 repeating blah, 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 blah. Now, this is a decimal. This is not a percent. So what you're going to do in order to turn this decimal into a percent is you multiply it by 100. The trick that you could use instead is move the decimal to the right twice. So what we have is negative 22.22%. Are we going to circle that and call it a day? No, because they want us to round it to the nearest percent. So negative 22.22 is closest to negative 22%. And that's what we're going to call it. Now, if you're wondering, like, what's that negative mean? That means our number went from a large number to a smaller number. So we're decreasing in value, which means it's a negative percent of change. So there you have it, donezo.